Well, at long last, it's finally time for us to start to take a look at functions. Functions are those verbs that we've been using all the way throughout some of our other lectures. It's a way to write reusable code by writing a chunk of code and giving it a name. And we can execute that code simply by calling the name. Functions are a really important part of our learning curve because it's where we really start to move from beginning programming into intermediate programming. The ability to section off or modularize our code according to functions is a really important step in that process. Functions are to code like paragraphs are to prose. So being able to divide our code up, to work on it in smaller chunks is a really, really important part of leveling up Python. Well, because it's with functions where we really start to move from beginning programming into the intermediate levels, we are going to spend a fair bit of time on functions. And so we're going to have a number of different slideshow lectures here, and we're going to do a fair bit of work in the terminal window too when we start to play with things. In short, though, a function is just a block of code that happens to have a name. Other languages might call them things like subroutines or procedures, and so you may have heard of those before, especially in pop media stuff. The cool thing about these blocks of code, though, is that we can execute them simply by saying or calling the name, right? Executing the name in our Python script. And we've seen functions all the way through. In fact, we've seen functions since the very first day we started working on things. Print is probably the most famous function that we've used up until this time. But you can see there are a couple of others here. There's list. That's going to turn a string into a list of 4 characters. Len is another one that we've played with. Len takes a sequence like a string or a list and tells us how many elements or how many characters it has in it. So all of these sorts of functions take generally some kind of input, and they give us something back or they perform an action for us. And that's why since the beginning I've really called them verbs in some sense, because they perform an action or they embody a behavior. They maybe make a decision for us or they do a calculation for us. But there is some sort of an activity that happens there. But using functions is an important part of leveling up in Python because it's like adding paragraphs to your prose. You wouldn't want to write, a 10-page paper all with one paragraph. You simply can't find anything in there. And similarly, when we get to more complicated programs, which we're starting to do now, we are going to divide those up into functions so that our code is even more modular than it was before. That makes it easier to comprehend and easier to find mistakes and problems when they occur. Generally what happens, though, and this makes sense and you're probably already aware of it even though we haven't talked about it explicitly, is that when we call a function from our code, Python temporarily puts our program on hold and control or execution passes over to the function where execution happens before it returns to us. So when we call a function, that is to say, name it or begin a transaction with that thing, like here, for example, we're just using the len function. So we call the len function and we send it some input. Len goes about doing its business. And at the end of that process, it returns to us something that we want to see. In len's case, it's going to give us a number. Now, usually that's a kind of a transaction, right? You can almost think about a function like a bank machine or an ATM, right? You go and you put in your card and you type in some key code things, and lo and behold, out comes some cash. It's that transactional nature of a function that is one of the defining features that it has. Now, sometimes it'll give us something back, like the cash machine gives us cash, or the len function gives us a number. But some of them, like print, don't really give us anything back. They just do something for us. And that's fine too. So just take an example here. Let's say we pass the word banana or pass the string banana to len. What len is going to do is just count up how many letters are in there, right? So we're going to get the number 6 back in return. So again, just to repeat, what happens is we have a Python script that we're writing, this green box here on the left. We've got some sort of a function. Maybe it's one of them that's built into Python. Maybe it's one we wrote ourselves. We're going to see that here in just a little bit. What happens is that our script starts at the top, and eventually there's a function call. So Python execution moves over to the function, and we execute the function just like we would a little script. It starts at the top, and it works all its way down to the bottom. And the function either performs its action or sends something back to the script. But either way, control returns to the script that we're writing in exactly the same place where we left, and we just continue on down to the bottom. Where are functions? Well, there's a lot of different places we can find them. Python has lots of these ones called built-in functions. Sometimes they even abbreviate like BIF, and so you don't have to do that. But anyway, a lot of built-in functions like len or open, which we saw with files, or list, which turns a string into a sequence, or print, or min, or max, all kinds of things. We even said there's dict, which we haven't really used to build a dictionary. But we don't really need to know where these live because these functions are always available to us. They always live in the ether in the script that we're writing, and that's why they're called built-in functions. They don't need a context. We don't need to find them in a module. We don't have to do anything. They just always exist, and they're always available to us. But on the other hand, we have seen functions that live in modules. We've used the random module. We've played a little bit in the math module. In one of the last lectures, we were looking at the requests module. And each one of those modules has built-in functions. So what we do when we use those is obviously the first step is we have to import that module. We have to import random or math. And then we can start to specify the functions inside that we want to use. So if we want to choose a random integer or a random number, we have to import the random module. And then we need to specify to Python where that function lives. They obviously live inside the random module, so we say they live in random dot name of the function. And by the way, I'll often do this. I'll repeat this often. I often list functions with the parentheses behind them. That technically maybe isn't necessarily a part of their name, but it is a classic way to not confuse these for variable names, right? So if you see cosine, COS with brackets or parentheses after it, you know that COS is not a variable name. You know that that is a function, right? And similarly, we played with the requests module. We called the get function, we passed it a URL, and what we got back in return was a requests object that had tons and tons of data in it. And that's actually the third place where functions live. They live inside objects. Now, in an earlier lecture, we talked a lot about data structures in Python and how they were objects, and that meant that they had these two parts like the Death Star, right? They have things they know and things they do. Those things they do are just functions. That's it. But when those functions belong to an object, we call it a method. Now, in this particular case, we can't call any of these functions unless we happen to have at hand the object that they belong to. So for example, lower and strip and upper and split all belong to a string object. So that means we can't call lower or strip or upper or split unless we have a string. And the same thing for a list, right? We can append to a list or extend a list. We can find the index of a particular element in that list. We can sort a list. We're going to play with that a lot later. But we have to have a list in order to tell the list to do those things. And the same with files, right? We can read from a file or read lines. We can close a file. We can write lines to a file. But we need to have a file object in order to do those things. So these are those three places then, right? So we have a lot of built-in functions that in effect have no context whatsoever. They're always available to us. There are certain other kinds of functions that belong to modules. We have to import the module, and then we can call that function. And then finally, we have functions that belong to objects, and we need to have the proper type of object at hand in order to call any of those functions. And again, when it belongs to an object, we call it a method. The important part about all of this, though, is that now we can begin to write our own custom functions. Every project that we do is going to have its own logic, it's going to have its own verbs, it's going to have its own behaviors or actions that need to be done. So being able to write our own functions is, again, like being able to write a really long essay with paragraphs. So let's just imagine that we want to program a robot to make pizza. I know this is kind of a dumb example, but let's just go with this one for a moment. We're going to make pizza, and we could write that as one long program, but we gain a lot of advantages if we divide this process down into smaller tasks, like mixing the dough and rolling it out and adding the toppings and baking, etc., etc., etc. Because in each step of that process, there are certain decisions that we can make. And in fact, we can give our customers choices, and the functions can adapt themselves based on those choices. So for example, mixing the dough, maybe we give our customers the choice between traditional crust or whole wheat or gluten-free. And so those are input pieces of data that we could send to the robot in order to mix the dough. And similarly, rolling out the dough could be a traditional crust or a thin crust or a pan crust. And then, of course, the toppings, you've got 80 million gajillion different kinds of combinations of ingredients that you can get from the menu. But then, baking it is time and temp, and how many slices do you do, and what's the box size. So there's a lot of other information here that is input into those sub-tasks, right? So this is why I think about functions as verbs so much. It's like, to do this thing, what are the steps? To mix the dough, what are the appropriate steps for that, right? Getting the ingredients and mixing it up. What are the steps to roll out the dough if it's a thin crust pizza, right? What are the processes of adding toppings? To add the toppings, we have to go to the fridge, add over, et cetera, et cetera, et cetera, right? So this is why I often think of functions as verbs. And in fact, as we'll see here towards the end, some of the kind of, I don't know if you want to call him a philosopher of coding, says this exactly as well, right? That functions are really the verbs of the entire system. Now, the nuts and bolts of it, in Python, a function is written using a template like this, and we're going to go through this a couple of times. It's not actually very complicated. In fact, you can see there's a suite or a block there just like there is in everything else. Like once you get that indented pattern for Python down pat, it shows up everywhere, right? The key word here is def, right? Short for define. We're defining a new function. And so anytime Python sees that def keyword, it is going to expect a block or a suite after it that is the definition or the embodiment of that function, right? It's going to have a colon at the end, just like it did with an if-else or a loop or a with block or anything like that. And if there are any inputs to this function, we're going to list them inside parentheses here or inside brackets. Now, some functions don't require any input, and that's okay. Some functions require a lot of output, but we get to make that decision when we're writing our own code. Obviously, there's going to be a block or a suite here. These are all indented statements, just like we saw with a with block or loops or if-else. And the definition of the function just continues until there are no more indented lines. So it doesn't matter if there's 1 or 2 or 1,000. All of those would be totally legitimate for Python. Now at the end, it's optional for us to return something to what we say, return it to the caller or return it to the main program. Again, this is a part of that transactional nature of functions. If I send len the word banana, len will return to me the value 6. Now that's not a requirement to return something For example, print doesn't return anything. But a lot of times we're going to write code, we're going to write functions where it needs to perform a calculation or make a decision. And so returning something to the caller is going to be really important for us. So here's a really simple one, and we'll do this on the command line in a little bit. Now I gotta confess, this is too simple. This is too simple for a function, but I don't want you to be confused by what's happening. I want you to pay attention to the structure and the syntax and how we write a function. So nobody's going to get confused by the concatenation that's happening here. Nobody's ever going to convince you that concatenation is so difficult that we have to write a function. But let's look at the structure and the syntax of it and look at the parts that are going on, right? So the name of this function is full name. And again, the name has to be one word long. It's just like a variable. And I often write the name of the function with those parentheses. After all, full name by itself could be a variable name. But when I put those brackets on the outside, when I put those parentheses on the end, that tells me that I'm actually referring here to a function. And there are some languages and some things like databases where every time you list a function like this, you must put the parentheses on there. It's not optional. In Python, as we'll see, we can leave this off in a little bit, but we'll see that here in a little bit. So anyway, the function has a name. Here, it's full name. The function is going to receive input in two variables, and these are just bucket variables, really simple. One's called first, one's called last. So when Python sees that, Python will actually create those two buckets or create those two variables. They will receive incoming data, and I think of these sometimes as catcher's mitts. I know we just did a baseball thing, but it's not that I'm obsessed with baseball, but it's a good metaphor. So you can think of the main program as the pitcher in some sense, who's going to throw the ball or throw the data. And these two variables in the function are like the catcher's mitts. That's what will catch or receive the data. So in this case, the main program is the thrower or the pitcher, and here the function is the receiver or the catcher. Well, the body of this function, it only has one line in it, really. And what I'm doing is concatenating these three strings together, and I am putting them into a new variable called name. So obviously what it's going to do, it will take the value of the variable called first, and onto that it will concatenate one blank space, and then onto that it will concatenate the value in the bucket called last, and assign that to a new bucket called name. And then finally, what the function will do is to return to the main program, or to return to the caller, a value. And here it is whatever the name bucket contains. So the value of name is the thing that will be returned or thrown back to the main program. And it's really the main program that's responsible then for catching it and for doing something with it. So you can see that part of the guarantee or part of the contract of a function is this kind of separation of powers between the main program and the function itself. We don't know what kind of data is coming into the buckets called first and last. We're going to concatenate it, so we kind of hope it's a string, but we don't know what's coming in. We don't know what that data is going to look like. All we know is that it is our obligation as the function to concatenate those values together and then return the result to the main program. What does the main program do with it? We have no idea, nor do we care. Our responsibility is ended as soon as we return it to the main program. Now in a script, it'll probably look like this. We'll do this here in the terminal window in just a few minutes, but let's pretend this kind of light green box here is my script. Maybe I did that in Atom or Sublime or BBEdit or some other text editor, and then I'm going to run this on the command line. So you'll see up at the top of my script here, I have that function, define full name. We're going to talk about this a little bit more in a few minutes. These have to go up towards the top, and we'll see why here in a little bit. So the functions are almost always at the top. So this is the function just as we just saw it. And then down below, you can see what's happening is that I'm calling full name and I'm sending it two strings. I'm sending it William and I'm sending it Shakespeare. And I'm going to put that into a new bucket called writer, which I print to the screen. So even though that function is defined up top, it doesn't execute it. When Python looks at it, it says, oh, well, gosh, I see here you're defining a function, so I will log in my internal private memory where that function actually lives, so that if in the future you happen to call it, and by future I mean farther down in the script, if in the future you happen to call it, I'll know where it is. So the function does not get executed when Python first sees it, but Python registers, oh, there's a function, it's called full name, here's where it lives. And then when I send it data, the data goes into those variables in the same order that I have listed them. So I am listing William as the first string, so that goes into the first variable listed, which of course is called first. Shakespeare is the second string, and so that goes into the second variable, which here is called last. So they go in exactly the same order. They go into the buckets or those variables in exactly the same order when I send them. And of course, then what I get back from the function, the return value from the function, I am storing in a new variable called writer. And then I print that out to the screen. A couple of little terminology things here. Up here, when I'm defining my function, those variables are called parameters. And so sometimes you'll see that or hear that written about or say, what are the parameters for this particular function? And what it means is, what are the variables that I am sending or that will receive my data, and what kind are they? What does this function expect of me? And we're going to see more about that soon. In fact, we'll see how we can figure that out even for stuff that we write. Now down here, the data items that I'm sending are called arguments. And you'll see these two terms used a lot, arguments and parameters. And in fact, if you mix them up, I don't think anybody's going to care. It doesn't really matter one way or the other. Maybe as a thing on a Friday, maybe you can try and start a bar fight. Like, is there really a difference between parameters and arguments? Anyway, we'll find out. I will probably use them interchangeably, but technically speaking, up at top, when we define the function, those variables are called parameters. And when I send data, those data pieces are called arguments. Even if they're in variables, they're still called arguments. Now that whole definition up top is called the function's signature. And that's going to be really important because when we look up functions in the Python documentation, or even when we choose to document our own functions, we will see the signature of every function. And in fact, this is what learning those functions in Python is all about, is really learning the signature. What's the name of the function and what are the parameters that it expects? All right, well, here in the terminal window, I'm just going to jump into the Python interpretive shell. And I want to build that function. I've already taken the liberty to type it out, and I'm just going to paste it right here. You can see I've got my def full name at the top with my colon. I have indented the block with name and the return of name. And if I hit return a couple of times, there is my function. In fact, I can ask Python, what is full name? And it will tell me it is a function, which is terrific. And now I can call that function and I can send it some data. So let me just send it Will and Shakespeare. Oh gosh. And you'll see what I get back, right? The interpretive shell just prints out the result, whatever that happens to be. In this case, it's Will Shakespeare. But I can, in fact, if I do this, I can put this, what did I do? I did writer. Oh, it doesn't write. There you go. So I can take the results and I can put that into a variable at the same time, right? So I can treat that return value in any number of ways. And in fact, I can even do this. So just bear with me for a second. If I just want to print that out, I can't spell print. I'm just going to put an extra space in there so that you can see a little bit more clearly what I'm doing. So you'll see here, I'm calling full name with the two arguments, Will and Shakespeare. And what I'm doing is I am sending that result to the print function. So the first thing that will happen is that Python will call the full name function, and whatever I get back, it's going to be a big surprise called Will Shakespeare. We will print that to wherever we happen to be. Here, of course, we're in the terminal window, but we could be on the command line, or we could be in a Jupyter notebook, and you'll see what we get. And again, right, the difference is when it just tells me what Will Shakespeare is or what the full name is, it does it as a string, but when I print it out, it just leaves off the quotation marks, right? So I can call this now with all kinds of other data if I wanted to. I'm just going to cheat a little bit and edit that line. Let's see, instead of Will, that was Kit Marlowe. And so you can see what happens. So what I've done is I have, in effect, created a verb that says to concatenate these two pieces together, to concatenate these two strings together. And so what I get back is this result, but it's an action, it's a behavior. It's a behavior that I have given a name to, and so simply by calling the name, I execute that code. Now, here's what's really interesting. I want to show you this before we go on further with the lecture. We talked just a minute ago that these two parameters up here, first and last, are buckets that are created by Python when that function executes. And in fact, here's another one. We create a bucket inside the body of the function called name. Now, does name have a value? No, it doesn't. Look at this. This is really interesting. Name, the name is not defined, so I'm getting an error there. Well, what's in the bucket called first? Well, the same thing. That is not defined either. What is in the bucket called last? No, that's not defined either. Is writer defined? Yeah, it is. So if I go back up here and I take a look at this, there's some really interesting thing happening. We're going to talk about this next, and it's a really, really important thing to learn about functions, is that outside the function, Python can't see the variable first, nor can it see the variable last, nor can it see the variable name. So these three variables belong to the function, and they do not belong to the caller. They do not belong outside the function. And outside the function, they have no definition whatsoever. Well, we're going to pick up on that idea in the next lecture, whose topic is variable scope, and we'll explore the dynamics of why that weird thing happens.